Is that the right one? I think that's the right one.
Sorry?
Is that the right one?
That's what you described?
How do I switch it on?
Let's wait just 1 minute. There's no time here.
It's 39.
You're still on US. That's why. It's 1:40. Okay, I think this is the right time to start this talk. My name is Jean-Marie Verdun. I'm here with Arun. We both work for HPE in the US. We are working into the advanced engineering team, mainly focused on open source firmware. This talk is, in fact, a follow-up talk about a tool that we open sourced a couple of years ago called OSFCI, which we brought to the Open Compute Foundation. Just some quick background about that tool. We designed the tool when the pandemic hit us about 3 to 4 years ago, and we were firmware engineers. And the main behavior that we had was to hack and debug firmware with a working system at work on a workbench. And when the pandemic hit, I didn't have any servers at home, and we needed to adapt with the virus issue that we had to face. And the only one place I could find to host a server was under my bed. So which explained that picture taken by my wife about my new working condition and our new home. And what you do not have on that picture is the noise of the server, because when you develop firmwares, one of the challenges is that the fan control is not working properly at the beginning, and it could be super noisy, especially with brand new machines. So I took a decision saying, okay, we probably need to revisit the way we design firmware, at HPE at least, and design a tool which gives us the opportunity to break a node from an internet connection and recover the node without having any people into the labs. And that's the main purpose of OSFCI. So how can we automatize firmware development, including node recovery and node breaking and getting feedback just through a web page, and ideally from an iPad. So can I develop firmware directly from an iPad on my couch in the US or not? So what we have done is we started to tweak the hardware. That's the main benefit at working at HPE. So we have motherboard engineers, and we started to remove the permanent storage, the spinal flash, and replace that by FPGAs. So like that, we can emulate the spinal flash on the systems. And we connected these FPGAs to well-known machines, which is not supposed to crash. And we can create various kind of clusters. And then we started to create some Docker environment just to compile the firmware and feed the FPGA and being able just to start up the machines remotely. All of that worked as expected, and we ended up with a very great tool. And that tool has totally changed the way we design firmware at HPE. It could look like a little bit weird, but even if the pandemic is now gone, the great news is that we still can work from home, even if the company wants us to be more in the lab now. But with that said, we are still using the tool, and we are seeing a ton of benefit at using this tool. And we are now working at making it scale for our end users, because we first use it internally, but now we have an external services which is giving the opportunity to our customers to test open source firmware on HP hardware without breaking their own hardware into their own labs. And the main purpose of these tools is to explain you what we have done to improve the tool and make it scale with, I would say, hundreds of potential test nodes instead of having just a couple, because we are having some kind of success with the public instances, and you might have to experience some wait time just to get a session on one allocated hardware systems, and that's a big pain for our end users, and we are just trying to improve that. So Arun is going to run a quick demo of the tool. He's one of the lead engineers developing it right now.
Thanks, Jean-Marie. So before we get kicked off on the demo, I just wanted to get through a quick workflow of how the demo will go. So anyone in the room can actually get their own account. So it's a public usage node. We are collaborating quite a bit with the OCP Foundation itself. So you will see some lead-ins to that as the talk goes along. Roughly, the demo will walk you through how you could build your own custom build of OpenBMC, Linux boot, and then you can load that particular firmware that you've just built, and then you can power on your machine. And if you see, you've got these neat options where you can enable the BMC web interface, and you can run your contest tests, all from the comfort of, like Jean-Marie said, your couch. And so this is something that we're working quite a bit with OCP right now, where we are going to have community tests and things like that. You could also use the tool from an API, which means that you don't have to use the web front end. You can simply write your own scripts that will leverage all of it. And so now I think it's a good time to get to the demo. So like with all cooking shows, I've cooked things a bit before. We weren't exactly sure how much time we would have to demonstrate. So let's say that you were working on this particular tree and this branch, and then you went ahead and you can simply hit build, and it will go and build your image. And as you can see from the message, it says the image was successfully generated. And then you can say, load my firmware. Hopefully this should work. So it'll load it on. We're using a bunch of EM100s. All of it's on live hardware. There's no QEMU involved. This is all live hardware execution, which is one of the beautiful things about this tool. Similarly, you can do it for Linux boot. And I know JM doesn't like me going up and down, but yeah, it's loaded. So now we can just hit connect power and see how this machine is going to work. Yes, no, it's not stuck.
Just to let you know, the machine is based in Houston, so we are using just a basic browser on the Windows computer, and everything is currently sitting into a colocation site in Houston. So we do not have any latency issues, and you can use the service from everywhere around the world. So this is currently booting OpenBMC on live. Which system do you have? The
DL360, yeah.
On the live DL360 Gen 10 platform. So we are currently upgrading the infrastructure to get access to Gen 11, which includes Genoa and Sapphire Rapid and Ampere system. Oh, sorry.
Sorry, what?
Need to speak in the mic. Yeah.
Okay.
So as I said, so the system which is running is the DL360 Gen 10. We are upgrading the CI to accept AMD Genoa, Sapphire Rapid, and Array 300. And that's also why we are improving the tools, because we are getting a wider scope of supported platform with OpenBMC, since we are supporting OpenBMC officially now on Gen 11 system. And we just want to give more opportunity for our end users to test OpenBMC at scale through that infrastructure. So what you see there is OpenBMC booting on the system. It's a little bit slow, but it's related to the fact that this is OpenBMC on a slow ARM Cortex A9 CPUs with a low amount of memory. But it will go up to the end, and if everything goes well, so we might be able to connect directly to the OpenBMC web UI, which is also super useful for the end users and to validate and test the whole functionalities. Just have to wait a little bit. I think it's getting close to the end. So, yeah.
You've got the shell. So hopefully the green button will show at some point. In the meanwhile, I can also show the fact that, like I said, you don't need to use the web front end. You can write your own scripts and use our API. So basically, the web instance is powered through the API calls. So you are free to deploy your own. You can write your own scripts, so you don't need to necessarily have in fact, this piece would be a big part of all of the automation that we're building with OCP and with HPE, because most of these tests are supposed to run without any human oversight. So it allows for that. So as Jean-Marie was saying, you've got your nice little shell, but you also have the option to go into the web console. Hopefully it should work. I'm curious, does anyone in the room know the default password to OpenBMC? Okay, so yes, so now you have the full web interface as well. Do you want to show off something here?
No, that's good.
And this is a piece that we're working on quite a bit with the OCP Foundation, where you can run a test directly on the SUT. So in the future, you will see this a lot more busier, and you can also write your own custom tests. So you can load these standard tests, and then you can simply hit run and execute these tests. And again, you can do all of that through your API. So again, this sort of shows you the glue of how things will look once you have full automation. And of course, you have your shell here as well. So let's get back to the presentation. So the original architecture it was the baseline for how we started. Jean-Marie architected this back in the day, so it's modular, it's written in Go. We have several endpoints supporting automation, including external frameworks like contests, and as the OCP foundations get further down into the DIAC core specifications and their community of tests, we also will be one of the first to feature that for the OCP. So we are kind of the primary demo platform at this point for that. It's fully open source. It's under the MIT license. The new architecture is interesting, and this is part of the reason for this talk, which is we wanted to get some savings on our colo space. And so we did this really neat thing. As I was telling, most of the system is one-to-one. So because it's live hardware, you don't have a lot of freedom to tweak. But the compiler node offered us an option of making sure that we can sort of share that across these multiple SUTs. So that's the work that we did recently, where before we would assign one compiler node to exactly one SUT, and that was part of the original design, but we felt that we can easily get some savings there. And so we did some neat containerization on top of the containerization that's already there. So we converted the original Go module to a container format where many instances could be launched on one unit. So this means that if you have usefully powerful vertical scale unit, you can have this compiler node being shared by many different SUTs. And we still maintain the original idea, which is that actually all of the rest of the parts is running on real hardware. And so this afforded us a remarkable 50 to 60% savings, because that compiler node would just be one part of the colo frame or the cage. The rest of the thing would multiply, but even that would allow us to have 50 to 60% savings. So per unit, it runs to about $2,400 per month for HPE to host this on the colo. And so right now we can do roughly 4 or more full compilation workflows with no cache. So this is pretty cool. So that was sort of the major tweak that happened. And like I said before, you can get your own account and you can make your own instance. So it's not rocket science. If you have all the pieces together, you can pretty much build your own. We have all the API examples for the things that I showed on the shell. An upcoming major release is from the community work that we're doing with the OCP DIAC team. So you can start integrating and offering tests from that pool. So this is the main focus for OCP. So we invite anyone interested in the room to contribute via pull requests, feature requests, and of course the DIAC efforts. Thank you.
Just as a quick conclusion too, I think the pandemic brought us into a new age of firmware development. So we jumped from doing everything by hand to full automation. And we bootstrapped that effort inside HPE, and we took the decision just to open it up to the community. And as Arun mentioned, I think the next core big things would be to be able to test automatically firmware image, including OpenBMC and Linux boot or core boot images, just to be sure that everything is properly set up depending on the end user environment. This is an ongoing effort which started about 18 months ago with other community members. I think it is going to be super active during the next couple of months, and we hope that we will have some very nice demo for the next OCP Summit, which is going to happen by the end of the year in California. The goal here is really just to help potential end users to adopt at scale open source firmware without having the fear of failing into their confidential environment setup and pre-qualifying the thermal response of the systems that they are building firmware to. So you are more than welcome to join the community, testing the tools. We are really open on any kind of ideas of improvement. I don't know if there is any question into the room. I think, as Arun mentioned it, the best option is really to test the tool and provide us feedback. Thank you. And if there is question, just raise your hand.
So I would have a question. What's the additional instrumentation that is needed to make it run? Like you mentioned some FPGA to emulate the flash device for the platform, if I got it correctly. But
Yeah, on the hardware perspective, what we have to do is being able just to remove all the firmware or envisioning that all the firmware might be failing, and how do we recover the systems? So we remove the spine or flashes from the motherboards, and this might be including also the one from the CPLDs, because we have CPLDs on the servers, and that might be another source of issues. We are also adding some USB devices to the servers for remote OS installation testing, because you can start, the main purpose of a firmware is just to start an operating system. So setting up the machine into a state where the operating system can start. So if we weren't able to boot an operating system, we thought that the tool won't be fully functional. And so we are offering the capability to have a virtual USB fully set up through the web interface with an end user operating system image that can be downloaded directly to the test units. So this is all of these kind of small tricks So then we also have the power configuration. How do you test the redundancy of the power supplies and all these kind of tricky things? So in the end, the first implementation was a massive mess with cables everywhere, and we set it up during the beginning of the pandemic. So we worked into very unusual conditions, only one engineer into the labs and all these kind of things. So now we are just trying to make it scale, and that's the key thing.
We also have a couple of EM100s, which is
yeah.
So that provides you the live swap out capabilities. So even if you brick the server, it's not really bricked. You can sort of reset it and go at it again.
It was a fun project at the beginning. A little bit stressful due to the condition, but in the end it was really fun just to try to figuring out how to fix that issues. Yeah.
Why you have been using USB? You can use mounting the networking for
That is mainly because at the beginning networking was not working, and you know, when you bring up systems, it's always easier to work on basic protocols, and USB is way much more basic than Ethernet in some way, and that's why we relied on USB first. So now we are testing, we are adding some features like how can we boot the BMC from the network too, just to test if that is doable, and we're just improving with time going on.
So that's actually a good way to also put the case for your own instance. If you're a large setup like us, you might not want to just rely on a public instance. You can have your own. Like we have for our engineering, we have a private instance. There's a lot more different server boards as well. So we are not locked into HPE hardware. In fact, OCP is a bunch of different hyperscalers. So you can add new boards as you like, and then the CI is able to work for all of them.
yeah, but normally with facilities now, you don't need transferring the keys out.
Yeah.
Everything is on.
We're also offering pre-built images. So if you want to test Ubuntu or Red Hat, they are preloaded on the CI interface. But if you have a very specific operating system, you have the opportunity to load yours. I'm sorry we're arriving at the end of the session. I'd like to thank you very much for coming. And if you have any questions, you might be coming to HPE booth. Arun and I are here, or you can contact us through emails. Thank you very much, and hope to see you in San Jose in November or October. I never remember when it is. Thank you. Thank you.